Okay, today we're going to show how to locate and drill on the center of a cylinder, and we're going to make a couple of assumptions for today's video. We're going to assume that you don't have a machine vise, it's not mounted to your machine, whatever reason, you don't have an already squared object. So the T-slots in your machine are squared to the axis, obviously. So what we're going to do is we're going to indicate using our edge finder. Now, yes, you can use an edge finder on a cylinder, but there are some issues depending upon the edge finder you may have and the size of the cylinder. So here's a great example. So by the time I get this edge finder tangent, you can see that the edge finder body is actually beyond the edge and could interfere with an accurate reading. This is overly exaggerated for the purpose of this demonstration, but I think it gives you an idea that if I were trying to indicate on this and I come down here, you can see that my edge finder isn't going to be able to become an accurate indicator at that point. So large stock can do that to you. So what we're going to do is we're going to show you using the T-slots in your table how to indicate, and then we're going to drill, spot drill on here to check center, and then we're going to go into our second method and use that as a verification of finding center. Okay, so here we go. We're going to go ahead and get our edge finder down a little bit. Got to bring my table up a little more. There we go. Let's kick the edge finder off, and here we go. There we go. Zero our first reading. Now I'm zeroing on the DRO. You can also use your dial. Okay, bump our edge finder. There we go, 4302. Okay, so we're going to take this, our 4302, cut it in half. Okay, and we'll see we have 2150. All right, so we're going to dial into 0.2151. All right, 2. There we go. And we're going to lock that. Now what we're going to do is turn the machine off, retract our quill, and just put in a spot drill, a center drill, just to verify that we are indeed on center. Bring the table back down. Bumped my handle. Go back to our 2151. Here we go. And I've already marked my offset here, so we're just going to bring this down. And just peck a little drill mark right there. Okay, there we go. Now that's not bad. I'm going to come forward a little bit so you can see. Visually, we're pretty good right there. So we're going to go ahead and take this out and show you another way that we can go about doing this same thing. Okay, bring the table down again. Now this one's a little different. We have a 1/4 inch end mill here. And let me show you what we're going to do here. Okay, we're going to bring this down. Table back up. And what we're going to do is we're going to touch just until we dust this surface, when that end mill just begins to touch. And we're going to go back and forth until we've cut a flat that is the same diameter as the end mill. So basically we want to get a 1/4 inch flat in here. There you go, you can see our flat starting to form. That is obviously not a 1/4 inch, so we're going to come down a little bit more. No, we actually overshot it, but let me show you what we're going to do here. So we turn the machine off, put it in neutral, and what we want to do is orient the flats of our cutter, the widest part, at this spot. So let me grab my meter. Sorry, I had to step away to grab my glasses. I couldn't see that small area there. There we go. Now, what this is for, again, we're drilling to hold a small a small die in place. So there's going to be a set screw on this end that goes into the dimple. These dies, the set screws are 180 degrees apart, so we'll be able to drill straight through. With this gives you a reasonable level of accuracy. We don't need to get down to the degree of thousandths or probably even tenths. So what we want to do is just measure the distance from each flat. Now this is easier if you hit your mark the first time, because you don't have to go in and measure these. You can just measure the width of this overall, and then you're good to go. Here we go. Now remember, we're going for reasonable center for a set screw, 1.2 millimeters on that side. And we'll get in here. Have to go from a different direction. My clamp is in the way. There we go. Okay. All right, we're about 0.77. Okay, so we're going to come over just a little bit, and I'm just going to eyeball this actually. There we go. That looks pretty good. Make sure we're square. I'm not sure how well this is showing up on camera, but those flats look to me to be very, very close. Okay. Yeah, we're about 0.7 on both sides, so we are pretty close to center right there. So what I'm going to do is I'm going to zero everything on my machine, and we're going to put our spot drill back in and spot drill this and see where we come across. We should be pretty close to center. There we go. Now what I want to do, just as my validation, I'm going to measure that spot drill mark to the edge of my flat. Okay, 356, 356. Look at that, right there in the middle. And for what we're putting in here, those little set screws to hold that little die, that will be definitely more than accurate. So we can go ahead, lock our table in place, drill and tap our holes. Drop our oil, and we're off. There we go. Got our holes drilled. We'll chamfer this side, tap it, flip it over. So I'll remove that. Now I've got my tap here and I'm going to put it in my chuck, but I'm not power tapping this. This is only for alignment. It's aluminum, it's a small hole, it should tap fairly easily, especially with these spiral flute taps. So I'm going to take the machine and put it in neutral, bring the head down, give it some oil, and we should be good to go. There we go. Coming straight through, almost zero effort. I love these taps. There we go. We'll turn our part over. I know you're thinking, oh my God, you just lost all your alignments. Not such a big deal because we just need to be straight to the hole. And what we're going to do here, we got to chamfer that hole still. We're going to use our chamfering bit to straighten that piece back out. This works on this bit as I only have the single cutting edge. If you had a multi-cutting edge, this would be a little less accurate for lining this piece up, but you could still do it. And all I'm doing is rotating it left and right and sliding it back and forth while I put a tiny, tiny bit of downward pressure on the quill. There we go. Tighten back up. Oh, don't put it back in gear. There we go. And now a quick visual check before you tap if you wanted to. You can just take a look at that chamfer, and if it has an even radius all the way around, you know that you're pretty much centered. So go ahead and take this out and drop in our tap, and we should be good to go. Now I'm going to turn the machine on, but that's only to make sure my tap is straight. Okay, perfect. Back to neutral. Down we go. Touch of oil. And voila. Quick and easy. Centers found, drilled and tapped without using a square reference, just the table itself. So simple way to go about it. The first method, obviously, using the center finder and a DRO or your crank, the dials on your crank. You have to do the math and cut in half and et cetera, but you will get a more accurate hole. The second method of going through and using an actual end mill to cut, as you saw, we can get a very accurate hole there as well. However, that accuracy is only going to be as good as your manual measurements that you took here. So there's a little bit of give and take there. The larger the diameter, the less important a tiny degree of error is. You're still going to be very, very close to a tangential center. Small diameter parts, I wouldn't go much lower than this diameter, maybe down to an inch to try this, but your error ratio goes up considerably as your diameter goes down. So a real simple way though. I hope you enjoyed that. If you got any questions, just comment down below. I'd answer everything I can. Thank you.